the same force is applied on both of the knives, right? So one of the knife is able to sharply cut the object while another one fails.
Yeah.
You are applying same amount of force, 10 Newton and 10 Newton here, right? But due to the surface area, the impact is different here. Here the surface area is large, here it's small.
Less. Yeah,
so pressure applied here is less, while pressure applied here is more.
More.
Okay. Then we also talked about pressure in liquids as well, right? So how pressure is exerted by liquids, right? So liquids basically exert a pressure on the walls of the container in which they are put, right?
Yeah.
Okay. And here you will see the pressure that a liquid exerts on the bottom of the container will basically depend upon the height of the liquid in the container, right?
Yeah.
So for example, here we saw that in the bottom of the container, guys, we made a hole, and this height, this much amount of water or liquid was exerting pressure, and the pressure was maximum here, right?
Yeah.
Okay. Now the liquid will exert pressures on different points on the walls of the container having the same depth. Having the same depth, the pressure will be applied on different points, right? So for example, you have this container here, and here you have, if you take the bottom, right? So if you were to make a hole here or hole here, on both the sides, the water will come out of equal pressure, right? The pressure of the jet will be same, because liquids applies same amount of pressure on all points. Getting it?
Yeah.
Okay. And the pressure will increase with depth.
Yeah.
All right. Okay. So that is it about the liquids here. Now, next thing we will be talking about how liquids exert pressure, how gases exert pressure. Okay. So before we do that, we will be discussing some basic questions. We will quickly discuss these questions, right? Okay.
Yeah.
So the fundamental things in regard to force, as we have discussed earlier, like if two forces act in the same direction, they are added.
Yeah.
Right. F1 plus F2, right? And if two forces are acting in opposite direction, suppose F1 is greater. F1 is greater here.
Yeah.
It's basically the net resultant force is F1 minus F2. Net resultant force or the total force, that is F1 minus F2, right? Or let's say if the F1 and F2 both are equal, F1 and F2 are equal here. Alona, you tell me, if the force F1 and F2 is equal and it is being applied on an object, will the object move or will it retain its position?
It won't move.
It won't move. Okay. So here, if the net force is 0, that is F1 minus F1 equal to 0, the object will remain at rest. Okay. So having discussed that, let's discuss this question. Okay. So the question says that there are two forces. One is having magnitude 12 Newton, another one is having 25 Newton. And this 12 Newton is acting on a body on the left hand side, while the force 35 Newton acts on the body on right hand side. We need to find the resultant force. Right? It's
the second force is 25, right? It's written 35.
No, two forces now are acting on a body on the left side. The force 12 Newton and 25. Yeah. See this diagram that will assist you guys. Yeah. See over here. Okay. Now you guys are required to find the resultant force. What it will be?
That will be 37.
No.
The object will
Stop there.
the
Stop there. Stop there. Okay. The answer is wrong, but the thing is now.
That is 2 Newton. 2 Newton.
2 Newton, no?
Yeah.
Okay.
We add the forces on left and then we subtract. 35 minus 35 equals to 2 Newton.
Okay, that is correct, Arham. But now on, you guys will be required to give your answer in the chat box. Okay.
Okay. Okay, sir.
Okay. So here you will basically take these forces as F1, F2, and F3. We are calling them as F1, F2, and F3 forces. So F1 plus F2, since they are acting in the same direction, that is the left direction, we will add them. Okay. And another force is acting in the different direction.
Yeah.
This one is here, this one is here. So we will subtract F3 from it.
Yeah.
Getting it? So here it becomes
So can you
12.
give us another question regarding this?
Yeah, sure. 12 plus 25 minus 35. That becomes 37 minus 35 equals to 2 Newton. So the object will move where?
At the
It
left.
will move. Yeah, at the left.
At the left. Okay. Alona,
Yeah.
are you able to relate? Things are clear?
Yes.
Yeah. Okay. So the object will move in the left direction since the net force is acting on the left direction.
Left.
Okay.
Yeah.
Now take another question here. This is an object here again. Okay, two forces are acting in this direction, that is on the right direction. One is of 18 Newton, another one is 25 Newton. Okay, and two forces are acting on this direction, that is on the left direction. So one is 33 Newton, another one is 1 Newton. Okay, so the object will move in which direction? That is the question. Movement.
So in the chat box, right? The answer.
Yeah, in the chat box. In which direction? Okay, don't get confused between the IDs. The ID from which I have, you guys are able to see me, only Mohammed Sohail, not the full name. So on that one you are required to answer. Okay, so basically you will click on the chat box here. So here you will get the option to everyone. So click on everyone, you will get the option to send to me. Arham. Okay, that is correct. Han. Okay, good. Aluna.
Sir, I'm not able to send in chat box.
Just tell me the answer. I have get the answer of Arham and Arhan. So where will the object move?
It will move to the 34 Newton that side.
Which one? On which
Right
direction?
side.
In the right direction or left?
Right.
Right.
I'm in left.
No, it will move in the right direction.
Yeah.
Let's see how.
Oh yeah, 43. Yeah.
Exactly, no? So on the left
Yes.
direction, the magnitude of the force is 34 Newton. Why? The force applied on the right direction, it is 43. So it is greater by 9 Newton, right? Hence the object will move in the right direction. Okay. See another question. These are objective questions. So I'm numbering the questions. You guys have to just give the answer, give the options as answer. Question number 1, 2, 3, 4. Okay. Alona, you will not go in the chat section. Okay, so here you will get option 2, TO2. So then you, from there, you have to send your answers, right?
Okay, sir.
Okay.
Sir, I have sent 4 out of 2 questions. Do you check it?
I have got, let me see. Arham, okay. Marhan. Okay. Arhan. No. Arham, you have sent.
Sir, you did not get my answer.
I have got your answer. Okay.
Okay.
Okay. So you guys have answered. Okay. Aluna, I haven't received answers from you. Are you unable to send the answer? Like, are you having some difficulty there?
I'm
Okay, no issues. If you can just answer me here as well. Okay.
Okay.
Okay, I have received the answer from other two, like from Arham and Arhan. Okay, Arhan, you have rectified your answer right now. Earlier you told it's to be Pascal. Okay, anyways, so a push or pull an object that is simply called as force. That is the definition of the force. A
Force.
push or pull an object. The motion imparted to objects is due to the, like if an
Action
object
of
is moving.
force.
Exactly. So a force is being applied on it. That's why it is able to move. Okay. It is not
Yes.
due to the action of pressure. Someone has answered action of pressure. It is not due to action of pressure.
It
That
is
is a
not in
different thing.
unit area.
Exactly. It is applied on basically on the whole object. Right?
Yeah.
Okay. Then SI unit of force, that is pretty easy. Newton.
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 Right. In game of tug of war, basically a rope is
The
pulled
B.
into opposite direction. Pull the rope in
Yeah,
opposite
the
direction.
B.
That is B. Good. Okay. Any confusions to any of you?
No.
No, sir.
No.
Okay. Good. See next question. 5, 6, and 7.
Mm.
Sir, I sent all the answers.
Okay. Okay, good. Okay, Arham. Okay. Aluna, are you having difficulty in sending the answer? I mean, you just have to write the answer in the chat box.
I'm trying to write.
Okay, so you can just tell me the answer when I will ask you the answers. Just tell me the answers. Okay.
Okay.
Okay. Alright. So I have received the answer from Arham and Arhan. Aluna, send me. Just tell me the answers. What are the answers of question number 5?
Fifth one. A.
A. That is correct. Arham and Arhan, you guys also have sent the same answer. Good. Then
Sixth one. C.
C, that is 0. If the net force, the net force will be 0 if two forces are acting in opposite direction or are having equal magnitude. Okay, seventh one.
D.
D. Right. So if force is applied on an object, it will change its speed. Right. Mass will not change. It is a natural composition that is present in the body.
Yes,
Color
sir.
will also not change. Neither will the weight change, because weight is basically the force with which the object is being attracted to the planet.
Yeah.
Okay.
Gravitational force.
Exactly. Now here one more question. A stone weighs 500 Newton. The weight of the stone here is given to be 500 Newton. Now you need to find out the pressure being applied by this stone if it makes contact with the surface area, which has an area of 25 centimeter square. So say I have taken an area here. Let's say it to be an area whose surface area measures 25 centimeters square. And this is the stone having the weight of 500 Newton. How much pressure this stone is exerting on the surface area? Let's say it to be a wooden slab on which it is placed. Okay, so you guys are
So will
required
the
to find
unit
the
be in Pascal?
What do you think? Obviously, it's going to be in Pascal now because we are
Sir,
calculating
I've
pressure.
sent my answer.
Sir, I'm also sending.
Okay, send the answer. Okay, that is correct, Aram. Very good. No, you guys have missed one thing here. Look here. See the unit here. The unit here is in centimeter.
Oh yeah.
You need to convert it, no? Arhan, your answer is also wrong. First, convert this unit here from centimeter square to what? Meter square.
Okay.
All right. Alona, you are solving?
Yes, sir.
Okay.
Sir, I've sent.
Yes, I saw that. Okay. Arhan and Alona, you guys are solving it?
Sir, I've sent it.
Look, guys.
Sir, I've
Look.
sent it.
Yeah, I saw that. Alona, what about you? What is your answer?
Sir, I don't know how to solve it.
Okay, look over here.
Hmm.
Force here is basically 500 Newton, right? Basically, this weight here is the force, right? Weight or force, they are same thing here. Now, the area given here is in centimeters square.
Yeah.
This needs to be converted into meters square. So how do we do that?
0.25. 0.25 meters.
It will be 25 upon centimeter into meter. What do we do
Sir,
that?
100.
Divided by 100, right?
So 0.25.
Sir, 0.25.
0.25. But you see, there's a square sign also here.
Yeah.
Getting it? So it needs to be divided again with 100. Getting it here? Look, it's like this. First, you convert 25 centimeter into meter. So that will be 25 upon 100, right? And we know that pressure equals to force upon area, and the standard unit says Newton upon meter square, Newton per meter square. So this is not meter here, but it needs to be, it is in meter here, but it needs to be in meter square. So 25 upon 100 square. That is 25 into 25 upon 100 into 100.
Yes, sir.
Getting it?
Yeah.
Yes, sir.
Okay, so that is how we are going to solve it then. Okay. Okay, so do one thing, just take this question as your assignment. Okay, and then we will move ahead then.
Okay, sir.
Okay, so take the screenshot of the question.
Sit done.
Okay. Arham and Aluna, you guys also take the screenshot.
Yeah, I've taken. Yeah.
Yes,
Okay,
sir.
good. Now there are some other questions as well. Let's quickly discuss them as well. Okay. Arham, see here. See pressure here. See the questions, guys, here.
Yeah.
So the first question says that is pressure directly proportional to area of contact, or directly proportional to area of to mass, to area inversely proportional to area of contact, or inversely proportional to force? So what do we know?
It's directly proportional to area of contact.
Right, because if area increases,
the pressure also increases.
Yes, sir.
No.
Sir, it
If
decreases.
area increases, pressure decreases.
Yes, sir. Yes, sir.
Yeah.
Oh yeah, yeah.
Yeah, and if area were to decrease, then pressure will increase.
Sir, the pressure will increase.
It's
Yeah.
yeah.
Isn't
It's
it, Alona?
inversely then, right?
Exactly. That basically means it's an inverse relation. Okay.
Yeah.
Now, two boys are exerting force of 40 Newton and 60 Newton in opposite direction on an object. Okay. This is an object. Here 40 Newton
Yes,
is
sir.
being
20
applied. Here
newtons.
60 Newton. The
Yes,
resultant
20
force is
Newton.
20
20
Newton.
Newton.
Very good. Good. Okay. Now, it is easy to walk on sand with flat shoes. Okay. Why is it so?
Because the area of
flat
the
shoes have
sole of the shoes is
higher.
more.
Hmm.
The flat
Okay.
shoes have a larger surface area.
Exactly.
And the surface area of the sole is more. That is no surface area, less pressure exerted on the sand.
Exactly. Exactly. Okay. Name an animal that has got a larger foot area.
Bear, elephant.
Exactly. Okay. And then you have example of camels in deserts that helps them to walk
Yeah.
easily.
Yes, sir.
Hooves.
Exactly. Small force produces more pressure on.
Sir,
Yeah.
Same
So
force. It's here. Same force.
sir, equal area.
Equal area. Exactly. Same force presses. Force produces more pressure. No, the question is more pressure.
Oh, okay, sir. Then it's larger area. Sir.
Hmm?
It's a smaller area. Smaller
We
area.
had an example of this knife. No, a blunt
Yes,
knife
sir.
and a
Yeah.
sharp knife.
smaller area.
Yes, sir. Yes, sir.
More the pressure,
Smaller
lesser the
area,
area.
sir.
Exactly. Alona, see the second question. This one here. Okay. The question says that same force will produce more pressure on which object? So you have this blunt knife. Okay. And you have a sharp knife. Same force of, let's say, 50 Newton is being applied on both of them. So more pressure will be generated in which one?
The sharp one.
Sharp knife, exactly, because of lesser contact surface area. Now, see this question. We have already, I think, discussed this one. Which of the following effect is not produced by force?
Change in mass.
Change in mass. Yeah.
Mass. Very good, guys. No change in mass is observed, right?
Yeah.
Okay. Now we come to another concept in regard to pressure and force. Okay. Before we even talk about up thrust, you guys need to know about thrust, right? So what is
Yes, sir.
thrust basically? Thrust is basically the perpendicular force applied on an object. It is nothing but the perpendicular force applied on object, that is basically called as thrust. Getting it?
Yes, sir.
That is what we mean by thrust here. So suppose we are having an object here and a perpendicular force is being applied. That force is simply called as thrust. Getting it?
Yeah.
Yes.
Okay. So there are some reactionary forces also. For example, this boat is able to float on the water. Why is it so? Because there's a reactionary force acting on this boat here.
Yes, sir.
Okay. And you see, whenever an object is immersed in the water, an equal amount of force acts upon the body. Okay. So any fluid you will see, the upward force exerted by a fluid on an object is known as upthrust, or also called as buoyant force. Right?
Buoyant force.
Exactly. So this boat here is also exerting a downward force that is called as thrust. And in reaction to this thrust, downward force, or let's say it to be a perpendicular force. You guys know what is a perpendicular force?
Yeah.
The force that acts as a 90 degree.
Yes.
Perpendicular. So in reaction to this thrust, an upthrust force acts by this fluid over here, that is water. That is simply called as what? Buoyant force or thrust force. So that is it about it. Okay. Now let's talk about how pressure acts in gases, right?
Yeah.
Okay. So for example, you have a container here. Okay. And we already know that the molecules present in the gas are more free than than solid and liquid.
Liquid.
The
Yeah.
molecules are free to move in random directions,
Yes.
right? So they are moving in random direction and hitting the walls of the container. Okay,
Yeah.
so there are so many millions of molecules present here, right? So
Mm.
the molecules of the gas are exerting pressure on the walls of the container. Okay,
Yeah.
so these molecules, we also know that they are having a higher kinetic energy.
Yes.
What is kinetic energy?
Okay, sir.
Hmm?
Um,
What is kinetic energy, by the way?
they're in constant motion.
No, they are having a higher kinetic energy. So kinetic energy is basically the energy possessed by an object or by an atom or a molecule while they are in motion. For example,
Yeah.
if a car is moving, the energy possessed by that car, or if I am running, the energy possessed by my body at that time will be called as kinetic energy,
Yeah.
right? Okay.
Yeah.
And let's say if I am sitting here, so my body is having a potential energy. Or if an object is placed at a height, if an object is placed at a height over here, so this object here is having a potential energy,
Yeah.
right? It is having a potential energy. So potential energy is basically energy possessed by an object while it is at a rest position at a height, right?
Yeah.
And kinetic energy is basically energy possessed by an
Emotion.
object while it is in
Emotion.
motion. Getting it?
Yeah.
Okay.
Yeah.
So here the particles, the molecules of the gases are continuously moving and hitting the container in which they are put. So here, since there are so many molecules, they are applying a large amount of force. Okay. And due to that force, pressure is generated on the walls of the container.
Hmm.
So it is here that the molecules of the gases exert pressure on the container, right? Okay.
Yeah.
Since they have higher kinetic energy. Okay. Now, you guys also tell me one thing. Like, if you have got a solid matter, if you have got a liquid matter, and you have got a gaseous state here. So, particles
Hmm.
of which medium will be having highest kinetic energy?
The
Sir,
gaseous.
the gases one, since it
Exactly.
moves freely around.
Yeah.
Exactly. It can move freely around. That is why. Okay.
Hmm.
And also you will see on each part of this container, equal amount of pressure is being applied.
Yeah.
Okay. So one another thing is equal amount of pressure is applied by a gaseous medium in a container. So when a gas is kept close in a container, equal amount of force is applied on the walls of the container. While it is not
Yeah.
true for atmosphere, right? Because if you go at higher heights, the pressure decreases. We will get to understand that
Yeah.
in a minute.
Yes.
Okay. So another concept here is the atmospheric pressure. What is this? Anyone who can explain this to me?
The atmospheric pressure is nearly most near the ground. It
Okay.
is the pressure exerted by the atmosphere around the Earth towards the Earth.
Mhm.
Yeah.
Basically, the thing is here, you have mentioned it very good here. That is correct. Okay. Basically, there's a layer of gases present around the Earth. That is basically a
Yeah. Atmosphere.
blanket of gas present around the Earth. That is called as atmosphere.
Yeah.
Right. Okay. Now, in the lower layers of the atmosphere, you will see the amount of gaseous molecules present are more denser.
More.
Right. So here in the lower
Yeah.
levels, that is the troposphere, you will see maximum amount of gaseous molecules are present. So the gaseous composition of the atmosphere, which we see, that is nitrogen, that is oxygen, that is carbon
Oxygen,
dioxide,
carbon dioxide.
right? So these are present in the lower strata of the atmosphere, that is in the lower layer.
Yeah.
Troposphere and in stratosphere. Okay, stratosphere is the same layer in which aeroplanes fly, right?
Yeah.
All right, guys. So in the lower layer, the concentration is high. Also, one more thing here is that there is so much air present in the atmosphere. That means there is so many gaseous molecules which are exerting pressure on the earth. So why don't we are able? Why aren't we feeling this pressure on our body?
Because the pressure is balanced inside our body due to the blood vessels. So the
Exactly.
outside and the inside
Our body
pressure is
has
maintained.
Very good, very good, very good point you have mentioned here, right? Like the amount of atmospheric pressure is quite large, right, due to the surface of the atmosphere around the earth.
Yeah.
But it is not experienced by our body. It is because the pressure of the air inside our body is equal to the atmospheric pressure. So where
they're
is the
balanced.
exactly they are being balanced, and where is this pressure coming from? It is coming from the fluids
Blood
that is
vessels.
moving in our body, that is the blood vessels, that is the
Yeah.
blood that is flowing in our body. Okay, so hence our body are easily able to obtain a balance with the atmospheric pressure, right?
Yeah.
Okay, so let's say this is the top of the atmosphere. This is the just I have taken a column of air, and this is the top of atmosphere, right? And let's say it to be the base. Let's call it the base, or let's say a surface. So on the top of the atmosphere, we will see that the composition, if you were to see in the base, you will see there's high composition of atoms. The atoms are densely spread. These are atoms. Okay, they are dense. As you rise above in height in the atmosphere, as the elevation increases, lesser amount of atoms, or let's say gaseous molecules, are found here, right?
Yeah.
See here how the composition, how the concentration is changing here. Getting it, guys?
Yeah.
yes.
Okay. So if you were to stand on a mountain top, over here,
Mm.
okay, and let's say there's one more person who is standing here at the base. Another person is standing here at the base. Another person is standing at the top. Right. Okay.
Yeah.
Here again, you will see, if you were to see the composition, the molecules of the atmosphere are like this here.
They're less.
While the molecules, exactly, while the molecules around this person are very dense.
Yeah, they're more.
Yes, sir. And he will have a hard
quantity.
time breathing properly
Exactly.
since
So
the
here,
pressure is so high.
no, the pressure is low here. Look here, the pressure here is lower pressure, because the amount of molecules present in the air is comparatively lesser, and they are at more distance, right?
Yeah.
So how many
Yes.
atoms are pressing down on this person standing here? How many atoms are applying pressure here?
And they're less.
They are less
Yes, sir,
comparatively.
compared to yes, sir.
While on this person, comparatively more amount of atoms are applying pressure. So here now, the force is the pressure is balanced. You will see balanced pressure. While here, the pressure applied by the body of this person is more compared to the atmospheric pressure. Hence, in many cases, you will see that blood comes out of the nose.
Nose,
right?
a nose bleeding.
Yes, sir.
Nose bleeding is observed here, right?
Yeah.
So, pressure inside body, at the body, is more as compared to atmosphere, right? So hence nose bleeding occurs. nose bleeding is observed, right? In fact, the person faints, right? And there is also
Yeah,
less
the blood
amount of
vessels
oxygen.
burst out.
Yeah, in many cases that happens, right? There is less
Yeah.
oxygen,
Mm.
right? So these are the challenges faced by the mountain hikers. Getting it?
Yeah.
Oh,
Yeah.
okay. Any confusion so far?
No.
No.
No, sir.
Okay. All right. Okay. So atmospheric pressure, it is basically defined as the pressure exerted by the layer of gases
Atmosphere.
on the Earth's surface, basically.
Yeah.
All right. So here we can basically conclude the chapter. We have discussed almost all the concepts. Okay.
Yeah.
Okay. Any difficulty faced by you guys in the chapter?
No.
No.
No, sir.
Okay. Okay. All right. So one more thing we can say that atmospheric pressure, can we not say that it is basically the weight of the atmosphere?
Yeah.
Weight
Yes,
of
sir. We
the
can say that.
weight of the atmosphere per unit area,
Yes. Yeah.
Yes, sir.
right? So we can also
Yes,
say
sir.
that as well, right? Okay. And by the way, what is the unit to measure atmospheric pressure?
I know the device.
Yeah.
It's manometer.
No. Unit to measure atmospheric pressure. It's actually 1 atm. 1 atm. Okay. It
Yeah.
is actually atmosphere. The unit is called as atmosphere. Getting it?
Okay.
Yes, sir.
All right. So that is it about the chapter. And exercise portion is left. You guys have to do the exercise portion. Okay.
Yeah.
Mm.
All right. So electrostatic force. You guys tell me about electrostatic force. What is that?
The electrostatic force is a force in which the charged
Mhm.
body or an uncharged body repels each other.
Charged body and uncharged body. If the body
Yeah.
is charged and another body is uncharged, then attraction will
Uncharged.
take place between them, no?
Yeah.
Okay.
Sir, electrostatic force is the force which happens when a electron or proton transfer into another body, and
Okay.
there are unequal amount of proton or electron.
No, that you are saying, no, that is another thing here. If the electron transfer from one body to another, it is due to the transfer of electron, that is the charge takes place. Notice the
Yeah.
term that is electrostatic. Electrostatic. So the body is static, basically. It is at rest. Getting it?
Yeah.
Yes.
So if I have got two objects, one object here, one object here, one has acquired positive charge, one has acquired negative charge, and both of them are rest. Getting it?
Yeah.
Mm.
The bodies are at rest. Okay, although they are at rest, but they have got unlike charge. They have unlike charge. Due to that, they will be attracting each other. So that is basically the concept of electrostatic charge. And as I told you,
Yeah.
why the body develops positive and negative charge, that is very obvious. A body will have equal amount of proton and electron.
Yeah.
Okay. So then our atom is said to be neutral. When the number of proton and electron, you guys know that an atom is basically made up of three fundamental particles: proton,
Proton, neutron, electron.
neutron, and electron. That is electron, proton, and neutron. So in an atom, naturally, the number of this proton and electron is equal. So hence it is said to be neutral, meaning same number of positive and negative electrons, negative charges here. Right. But what happens if the bodies are rubbed across each other? And from this body A here, some of the electron charge travels to body B here. So this body will gain some extra amount of electron. So this body will become negative. Since the charge of the electron is negative, the body will be negative. And since this body has lost the electron, suppose earlier it had 10 electron and 10 proton. Now after losing one electron, it has got only 9 electron. So the net charge here is
Yeah.
+1 now.
Yes.
So that's how body develops charge, right? Okay. Now while if this electron is moving in a live wire, In that case, electricity is generated, right?
Yeah.
So electricity, it is
Electrons,
generated due to
electrons
the
movement.
movement of
Movement
electrons.
of electrons.
Exactly. Okay, so that is it about the chapter. Next we have NCERT exercises. So we still have got 15 minutes. Okay, just give me a moment. Let me attach the NCERT exercises here, and then we will discuss that as well.
Yeah.
Okay,
Yes.
just give me a moment, guys. By the way, when your schools are opening, guys?
20th August.
28th of August. Okay, Alona, what about you?
Same.
Same.
Yeah.
Okay. Okay. And Arham, tomorrow, that is on 9th of August, as per here in India,
Yeah.
we can schedule the extra class for you tomorrow, like for your
Okay, no
holiday
problem.
homework.
Yeah.
Okay.
No problem.
Okay. If it gets scheduled, you will be informed, right?
Yeah.
All right. Okay. You guys can see the screen?
Yeah.
Okay. See the first question. Yeah. The questions are pretty easy. Okay. So basically the question is that give two examples each of situation in which
So I'm not able to hear you.
Sir, I accidentally left.
okay, sorry for the interruption. There was some technical issue here.
Yeah.
Okay. Just give me a moment here. Okay, while I'm sharing the screen, okay, you guys take out your books. Okay.
Yeah, I have my book.
Okay, just give me a moment, guys. Actually, I'm trying to share the screen, but currently I'm not the co-host. Just give me a moment, okay? Okay, you guys will be able to see the screen just in a moment. Okay.
Yes, sir.
Okay, guys. Okay. Thank you for having patience. There was some technical issue here. Okay, see, first question. The question is that give two examples each of situation in which you push or pull to change the state of motion of objects. Very,
kicking
very,
a
riding a
football.
very easy.
bicycle.
Sir,
Yeah.
kicking a football.
Exactly, exactly. Kicking a football, applying brakes to a
Pushing a cart.
bicycle. Exactly, exactly. Okay, next question is that give two examples of situation in which applied force causes a change in the shape of an object. Okay,
Kneading a
Alona,
dough.
Sir, clay. Sir,
Yeah.
clay.
yeah,
Sir,
very good.
stretching a belt.
Okay.
A rubber belt.
Mm-hmm.
Kneading
These
a
are all
dough.
these are all physical or chemical changes which you guys have gave example of.
Sir, physical. Since it can be changed into its original shape.
Alona,
Clay modeling.
clay modeling, right? Okay. Shape of the plastic ball changes when you squeeze it. Okay.
Yeah.
Stress
No.
ball.
Exactly. Okay. To take out water from a well, we have to push or pull the root.
Pull. Pull.
Sir, pull.
Pull.
Sir,
Very
pull,
good.
sir.
Okay. Next question.
Attracts and uncharged.
Exactly.
Attract.
Okay.
Yeah.
Okay. So these are pretty easy questions, right? Okay.
Hmm.
See question number 4. An archer stretches her bow while taking aim at the target. She then releases the arrow, which begins to move towards the target. So in this information, you have to fill the statements here.
Yeah.
The
The first
archer
will be shape.
shape, good.
Yeah, in shape.
That is an example of which type of
Muscular
force?
force.
Muscular force. Very good, very good. That is a muscular force. Okay.
Yes, sir.
Now there's few more questions in it. Yeah, C1.
Sir, C will be muscular force.
Okay. The questions are incomplete here. Yeah, here's the question. No, just that's a different question. Okay. We are still at question number 4. Okay. What about question number D, guys?
Sir, gravity for the first one.
And friction.
And friction.
Very good.
Yeah, gravity and friction.
Very good. When the arrow moves towards the target, the force acting on it are of gravity and due to friction of here. So eventually, due to these
Friction.
forces, the arrow falls back to the ground, right? So if there was suppose no friction, suppose there was no gravity,
Yeah.
what will happen?
The arrow will fall down.
So the arrow will keep moving forward.
It will keep moving further since it is having no resistance,
Yes,
right?
Yeah.
Okay, good. Now, question number 5.
Muscular force. A1.
A1 is muscular force, right? Good.
Second one is also muscular force.
Okay, third one, Alona, you answer this one. A load suspended from a spring while its other end is on a hook fixed to a wall. Identify the agent exerting the force and effect of the force in this case.
So can I?
Okay.
So can I?
Gravitational.
Okay, you can.
So the agent will be load and the effect will be expansion of the spring.
Effect will be expansion. And where will the force, which is the agent exerting the force here?
Sir, load.
No.
Load. And Alona, you tell me in which direction the force is being applied?
And
In the
Sir,
downward
both
direction, no?
direction.
Downwards, yeah.
Okay. Here, especially, it's in the downward direction. Okay. In which the motion is taking place. While this spring is also applying an upward force as well. Right? Okay. But the effect is due to the downward force. Right? An athlete making a high jump to clear the bar at a certain height. So here the athlete does what?
Queen.
This is the, let's say, feet of the athlete.
Yes, sir.
Okay. So while making the jump, the athlete is basically applying a force on the ground. Which force? Pull or push?
Sir, pull. The push. Sorry. The push. Yes,
Push,
sir.
push, push. So basically, the athlete is trying to push the ground backward. So this basically allows him to jump over the bar, right? Okay.
yes.
Yes.
Question number. Which question here? Yeah, this question number 6 here. A blacksmith hammers a hard piece of iron while making a tool. How does the force due to hammering affect the piece of iron?
It
Sir,
changes the shape.
the force of
changes the
hammering
shape of
will
the piece
change
of
the
iron.
shape of the. Yes, sir.
Okay. So what we will do now, we will have answer one by one. Okay. So I will say the name, then you guys will answer. In that way, I will be getting separate answers.
Okay,
Okay.
sir.
Okay, good. So that basically, here we are applying which type of force, Alona?
Which one are you doing, sir?
In question number 6.
Change in shape. Change in shape.
No, the question is that which force or which type of force is applied? Which type of force is exerted here? Is it muscular force, kinetic force, electrostatic force? Muscular force, right? Okay, that basically changes the shape of the iron to our desired shape. Okay, Aram, see next question. The question is that there's an inflated balloon and it is pressed against a wall after it had been rubbed with a piece of synthetic cloth. And what was found that it stuck to the wall. What force might have been responsible for this?
Electrostatic force.
Electrostatic force, that is obvious, right? Good.
Yeah.
Okay, Arhan, see question number 8. The force acting on a plastic bucket containing water held above ground level in your hand, right? Now, this is why the force acting on the bucket do not bring a change in its state of motion.
So due to gravitational force and muscular force. Since gravitational force is acting downwards and muscular force is applied by our hands.
Very good, very good. Force of gravity is pulling it downward while our muscular force is holding it. That's why the motion is not changing. It is at a stationary position, right? So there is no change in a state of motion of this bucket. Now, Alona, see question number 9.
Yes.
A rocket has been fired upwards. So what are the two forces acting on this rocket?
Force of gravity and friction.
Exactly. One force here is the force of gravity. Okay. And then this rocket is experiencing air resistance as well. Okay, that is also trying to pull it down. Okay.
Yes, sir. Yes, sir.
So it's also a mechanical force, right?
Mechanical force is being applied by this rocket here. Right.
Yeah.
Okay, good. So that is it here. Okay, one more question here. Aram, see question number 10. When we press the bulb of a dropper with its nozzle kept in water, the air in the dropper is seen to escape in the form of bubbles. Once we release the pressure on the bulb, water gets filled in the dropper. The rise of water in the dropper is due to the dropper. You guys must have taken medicines from this dropper. This dropper here that used to come in black color.
Yes, sir.
Yeah, so medicines were taken using this. Yeah. So how water gets filled into it? Is it due to pressure of water, gravity of earth, or shape of rubber? Or atmospheric
Pressure
pressure?
of water.
Pressure of?
water.
So, no, sir, it will be
So it
atmospheric
might be
pressure.
atmospheric pressure. Yeah, it might be atmospheric pressure because
Exactly.
the pressure inside the what do you say?
Mhm.
The dropper is
Mhm.
not